For 4 billion years, Earth has been under attack. The sun, bright and powerful, violent and relentless. This is the solar wind, a constant stream of fierce protons and electrons that can travel up to more than 2 million kilometers per hour, headed directly our way. Luckily, Earth has an invisible shield, the Magnetosphere. Without it, our planet would become a barren wasteland. But instead, our home is full of color, like the cosmic spectacle of the auroras. Visible evidence of the invisible battle between the solar wind and the Earth's magnetic shield. And for the first time in history, we are about to watch this shield in action. This is SMILE, a joint mission between the European Space Agency and the Chinese Academy of Sciences. Using its X-ray camera, SMILE will be the first space telescope to look at Earth's magnetic field in X-rays. By detecting the X-ray light emitted when charged solar wind particles interact with neutral particles in Earth's upper atmosphere, SMILE will give us our first view of Earth's protective gear from space. SMILE also comes equipped with ultraviolet vision to record the northern lights. It can record up to 45 hours at a time, the longest in history, giving us a complete view of the 2 to 3 day magnetic storms that cause the auroras. Its magnetometer will determine the strength and direction of the solar wind's magnetic field, detecting any shocks or irregularities. And its light ion analyzer will measure the charged particles that cross its path in 3 dimensions, detecting them all around SMILE. Together, these instruments form a unique toolbox. For the first time, we will see the solar wind's attack and Earth's response simultaneously. Because although we are protected, the solar wind can still affect us. It exposes astronauts to increased radiation during missions. It can damage our satellites and disrupt navigation, telecommunications, and weather services. Some of the most violent solar storms have been known to wreak havoc on our vital infrastructure, corroding railways and pipelines, and shutting down power grids. SMILE is essential in understanding the science of space weather, marking the first time ESA and CAS have jointly selected, built, and operate a mission together. SMILE brings more than 250 European and Chinese scientists and is funded by all ESA member states, making it truly a global mission aiming to study a global phenomenon. SMILE is set to launch from Europe's Spaceport in French Guiana this spring aboard a Vega-C rocket, Europe's versatile launcher. On a highly elliptical orbit around Earth, SMILE will reach up to 121,000 kilometers above the North Pole, before coming down to around 5,000 kilometers over the South Pole to send down data that will help us understand our solar system, improve our models of Earth's magnetic environment, and ultimately help protect us from the solar wind. We're still learning about the magnetosphere, and there are several questions yet to be answered. What happens where the solar wind meets Earth's magnetic shield? What causes magnetic glitches on the dark side of Earth? How can we predict the most dangerous magnetic storms earlier? With missions like SMILE, ESA is determined to go the distance to find the answers. We've never seen Earth's invisible armor like this before. SMILE will reveal Earth's magnetic field in action. Using X-ray vision, it will be the first space telescope to capture how Earth's magnetosphere reacts to the solar wind. Its ultraviolet vision will record the northern lights for 45 hours at a time, making this the first mission to study the solar wind's attack and Earth's response simultaneously. The European Space Agency and the Chinese Academy of Sciences have joined forces to study this global phenomenon. This month, SMILE will launch aboard a Vega-C rocket from Europe's Spaceport in French Guiana, ready to finally uncover the invisible forces that protect our planet.
SMILE is a space mission designed to watch how Earth's magnetic field reacts to the solar wind. But first, it had to be prepared for its journey into space on a Vega-C rocket. Let's take a look back at the last few weeks before liftoff. From ESA's Technical Centre in the Netherlands, the spacecraft crossed the ocean to French Guiana. There, SMILE was received at Europe's Spaceport, where final preparations began. After SMILE was unboxed and tested, it was fueled. SMILE carries 4 fuel tanks beneath its solar panels, holding hydrazine fuel and oxidizer. The spacecraft weighs 2,300 kilograms, and 1,580 of that is fuel. But in its first month in space, SMILE will use around 90% of this fuel. After launch and separation from the Vega-C rocket, SMILE will fire its engines 11 times in 25 days, gradually stretching its path into a highly elliptical orbit that reaches 121,000 kilometers above the North Pole. Fueling SMILE has been one of the most delicate parts of launch preparations. Hydrazine is highly explosive and toxic, handled only by a small team of specialists in fully sealed escape suits. Next, SMILE was connected to its Vega-C launch adapter. Known as Vampire, this adapter locks the spacecraft securely to the rocket during launch. Then, like a caterpillar in a cocoon, SMILE was enclosed inside Vega-C's protective fairing. Made of carbon fibre, this nose cone shields the spacecraft from heat, noise and intense aerodynamic forces during launch and ascent. This moment, known as encapsulation, marked the last time humans would see SMILE on Earth. Once the Vega-C rocket is beyond Earth's atmosphere, the fairing will split in two, introducing SMILE to space. Vega-C can launch over 3,000 kilograms into space, making a wide range of missions possible, from small CubeSats to larger spacecraft like SMILE. But before liftoff, it's assembled, stage by stage. Its first stage, made from carbon fibre, packs extraordinary power. In just 2 minutes, it delivers 4,500 kilonewtons of thrust, the equivalent of 15 modern airliner engines. Its second stage delivers around 1,300 kilonewtons of thrust, enough force to lift an empty Airbus 300. Vega-C's third stage burns 10 tons of solid propellant and will carry SMILE one step closer to orbit. Last but not least, the fourth stage, which provides precise orbital control using a restartable engine and 740 kilograms of propellant. The fourth stage will perform multiple burns to deliver SMILE to its drop-off orbit before a final maneuver deorbits the stage to reduce space debris. Finally, encased in its fairing, SMILE was lifted onto the Vega-C. From its journey across Earth to its final preparations at Europe's Spaceport, SMILE has come a long way. Carefully assembled, fueled and sealed, every step has led here. Now everything is ready. SMILE is set to leave Earth, beginning its mission to study how our planet responds to the Sun, and in doing so, advancing the science of space weather.
Hello there, a very big welcome to our YouTube live Vega Go. We're coming to you from the European Spaceport in French Guiana, and we're transporting an exciting satellite tonight. It's called SMILE, and it's going to help us better understand the magnetic field which makes life possible on our planet. It's a joint mission between the European Space Agency and the Chinese Academy of Sciences, and it's traveling on board a Vega-C rocket, 35 meters of European engineering. It's an important mission because for the first time ever, the Italian company which manufactures Vega-C, Avio, is also providing the launch, so it's a big day. We are 15 kilometers from that pad in the Mission Control Center, very much the nerve center of operations, looking down over what we call the fishbowl, the protective glass there around the operational teams. And with me in the commentary box is the head of flight mechanics, GNC, and flight software at Avio, Irene Cruciani. Irene.
Hi, Katie. I'm so happy and proud to stay here representing Avio for this first time in the commentary box.
Oh, and we're so happy and proud to have you with us. Irene, how is everything looking for launch today?
Everything is going well as planned. The status of panels is green and we are ready for launch.
That's good. That's what we like to hear. So let's go inside the fishbowl now to Giulio Ranzo, the CEO of Avio. As we said, Avio manufactures the Vega-C rocket, and for the first time, Giulio, you are also launching it, so it's a very important day.
Yes, indeed. Yes, indeed. This is one important milestone along a very long journey, which started in February 2012, so 14 years ago when we first launched Vega. Now we are taking charge for the responsibility of operations during flight. So it's a big responsibility, one step we have prepared for during so many years. So yes, we're very concentrated on the launch, very excited to watch this mission.
And tell us more about tonight's mission, Giulio.
Well, this is a very peculiar scientific mission. So it's a collaboration between the European Space Agency and the Chinese Space Agency. It's a scientific spacecraft which is attempting to measure a number of phenomena related to the sun emissions. So it's going to measure something around the magnetosphere that is all around Earth, and something very peculiar, the solar wind. So we're very excited to be able to transport to space a mission that will advance human knowledge around very sophisticated phenomena that are impossible to measure from Earth. So once again, very excited to do this. For the first time.
Indeed, and we're wishing you all the very best for today's mission. Giulio, thank you very much indeed. You can take up your position now back in on the flight desk in the fishbowl. Giulio Ranzo, thank you.
Thank you so much, Katie.
So, Irene, as Giulio said there, it's been a big journey for Avio. Avio is now in the space business, but let's get a little bit of history, because Avio was not always in space, was it?
Yes, sure. Avio started in 1912, more than a century ago, in the defense, then moved to chemical and propulsion, and entered space in the 60s. For its experience in solid propulsion, it became the supplier for Ariane program in the 80s, and Vega arrived in 2012. So with the maiden flight of Vega, Avio became launch prime contractor.
And that's really important,
Yes.
isn't it? It's also a very important milestone for Europe.
Yes, it's true, indeed. We balance European competition and ESA members' cooperation. We are at the same time autonomous, and we work jointly in very close relations with Ariane 6, sharing some key elements as P120 and P160. Together, we guarantee European access to space.
And today with Vega-C, it's really a historical first, isn't it?
Yes, it's really historical.
Yeah, Avio becoming a fully autonomous launch service provider and managing the whole value chain.
Yes, commercialization, preparation of the mission, and injection in orbit.
We are 16 minutes and coming up to 16 minutes and 53 seconds to launch our rocket, standing tall there on the pad, getting ready now to lift off. So let's take a closer look at what Avio brings to the European launch family.
In Colleferro, just outside Rome, the rhythm of Europe's launch capacity is forged in advanced carbon composites. For decades, Avio has been building propulsion systems powering Europe's launches into space. Today, that legacy enters a new chapter, a chapter that begins here at the Colleferro historic site.
As the operator of the Vega-C launches, Avio now assumes full responsibility for entire flight operation. This is a major milestone showing that Avio has reached full industrial and operational maturity. What makes me most proud is seeing our team turn their work in the real service for Europe. Every day our people enable missions, helping Europe reach space independently. It's a big responsibility and very rewarding.
It is here in Colleferro that the powerful P120C motor, Vega-C's first stage, is produced. A technology that reflects years of European cooperation and industrial expertise. But once assembled, the motor begins a long journey. More than 7,000 kilometers separates the factory from its destination, Kourou in French Guiana. Antonio Pizzacaroli takes over at the launch site.
With the new role of launcher operator, Avio can work closely with the satellite from the very start, understanding its needs, optimizing the mission design, and coordinating potential co-passengers. Engineers can define early on the separation system, electrical interfaces, communication and measurement systems, the launch timeline, and the optimal trajectory for orbital insertions.
At the Guiana Space Center, Vega-C stands ready. Designed for precision and versatility, the launcher is capable of delivering Earth observation satellites into precise orbits. Each launch is part of a broader vision, enabling missions that serve science, institutions, and commercial partners.
For customers, this new model means having a single partner, namely Avio, supporting them from contract signature to orbit. I believe that this streamlines communications and makes the overall experience smoother and more efficient. Avio's ambitions is clear: growth. We aim to consolidate our position as a trusted European launch service provider by increasing the annual number of Vega-C missions.
From the quiet workshops of Colleferro to the tropical launch pad in French Guiana, Vega travels thousands of kilometers. Years of design and testing, countless engineers, leading to one heartbeat of silence before ignition, as Europe's next mission rises to space.
Indeed, and there it is right now on the pad, 13 minutes and 20 seconds to launch. Let's walk you around some of the teams who are now under Avio's responsibility. Obviously, we have the flight desk. We saw Giulia Ranzo there going back to the flight desk earlier. This is very much the top management taking all the final decisions in the event of unplanned situations.
Then we can see the mission director is Claude Dupuis. Is the contractual interface with the customer for the entire execution of the contract, assuring project coordination. And he works closely with the mission operation manager, Rocco Albano, and his deputy, Antonio Pizzicaroli. They are the main operational interface with the customer, coordinating all spacecraft-related activities during the launch campaign.
And we also have the launch control teams in what we call Pandora. The launch control there very much concerned with the rocket and the pad. And we also have, after launch, the teams in the quick look telemetry.
Yes, Avio is now responsible also for the CVI, the team overseeing launcher telemetry in real time.
Now, Smile's scheduled to lift off in 12 minutes, Irene. What's going to happen after that?
Yes, the launcher lifts off towards northeast, with a launch azimuth of about 26 degrees from the north direction, powered by its 3 solid propellant stages, each one separating after finishing its job. We separate P120 at about 63 kilometers, while the second stage pushes the launcher up to 127 kilometers. The fairing is separated once the launcher leaves the atmosphere, just after Zeta 9 ignition, leaving the satellite exposed to the cold space. We are about 7 minutes after liftoff. After Zefiro 9 separation, there's a long steam phase of about 13 minutes up to the first ignition of the upper stage, that is the Avon Plus. The Avon Plus upper stage is then ignited for about 4 minutes, putting the launcher in the so-called transfer orbit. Then a second steam phase of about 28 minutes leads the Avon igniting for about 2 minutes to reach the target circular orbit at 700 kilometers of altitude, where the SMILE is separated, less than 1 hour from liftoff, less than the time needed to reach Colleferro from Rome with the car.
On your way to work.
Yes. And the upper stage enters in no costing for about 1 hour before a third boost to re-enter and to avoid leaving any debris space.
Very important, of course. So that's all coming up, but right now everybody's eyes across the base are on the status panels. They are all green there on the left-hand side of the screens there, and they're showing us the go, no-go status of all the different systems.
Yes, there are 3 main systems under control. There is the range with the spaceport and the tracking stations across the planet, the rocket and the pad, and the satellite. A bit like a traffic lights. Green means go, and red means stop. And everything should be green for launch to go ahead.
And that's the case right now, so that's good news. We do have a launch window today, don't we?
Yes. Today we have a window of about 40 minutes, so we can launch anytime during this interval. Good to have this flexibility.
Yeah, always nice to have a launch window. So let's talk a little bit about SMILE. It stands for the Solar Wind Magnetosphere Ionosphere Link Explorer. And we already have satellites studying Earth's magnetic shield, but SMILE's the first one to show us the big picture from a great distance, allowing us to analyse the solar wind hitting Earth's magnetosphere.
Yes, this is a fantastic science. It's thanks to a partnership between Europe and China, a 50-50 partnership. In fact, it's the first time that a mission has been jointly designed, launched, operated by the European Space Agency and China from the beginning.
For the European component, Airbus Defence and Space led the industrial teams who built the payload module. Our friends in China developed the platform and 3 of those instruments. And a shout out to my compatriots at the University of Leicester in the UK who developed the soft X-ray imager, SMILE's wide angle eye on the magnetosphere.
Almost 5 billion years ago, a star ignited. Ever since, the sun has never stopped breathing, silently shaping our planet's environment. Every second, our star releases vast numbers of charged particles, invisible currents traveling millions of kilometers through space towards Earth. A solar wind that never rests. We do not see it, we do not feel it, yet it is always there. Our planet is not defenseless. It is wrapped in an immense magnetic field called the magnetosphere. But when the solar wind intensifies, that invisible boundary trembles. Navigation systems can fail, satellites can be impacted, power grids can shut down, astronauts are exposed to radiation. The technologies that sustain our modern world suddenly become vulnerable. For decades, scientists have studied fragments of this interaction, but never the full picture until now. Its name is SMILE, and it will be launched by a Vega-C rocket.
The SMILE name was found by our Chinese colleague who did a simulation of the Earth's magnetosphere and what we would see with an X-ray instrument. Then they saw a nice smile, so they call it SMILE.
A joint mission between the European Space Agency, ESA, and the Chinese Academy of Sciences, with the launch operated by Avio. SMILE is designed to answer a fundamental question. How exactly does energy from the sun enter and circulate within Earth's magnetic environment?
2, 1, go!
Launching with Vega-C from Europe's Spaceport in French Guiana, SMILE will travel as far as 121,000 kilometers from Earth.
What makes SMILE even more special is that we have two imagers on board, and this is the first time that this is being done for this kind of missions.
Using X-ray and ultraviolet cameras, SMILE will make the invisible visible. It will trace the journey of solar energy, revealing where magnetic storms ignite and cause our skies to light up with auroras. SMILE will close a gap in our understanding of the solar system, ultimately helping to protect both our technologies and the astronauts operating in space. SMILE, a small satellite with a powerful mission to watch magnetic storms, to understand them, and to help us live safely beneath them.
Such an important satellite, and so much more than a satellite. It's very much a scientific handshake between Europe and China. International cooperation at its best. So we are getting closer now to the next big moment, which will be the beginning of what we call the synchronized sequence, or the automatic sequence. That's the last 4 minutes of the countdown. That's coming up in about 1 minute, Irene. That will be a big milestone.
Yes, we will gradually give the launcher the full autonomy to proceed with liftoff. Computers will be managing a complex sequence of operations. This involves several steps, including loading takeoff time, flight program software into the onboard computer, and inertial platform initialization and alignment procedure. It is the handover between the ground control and the onboard computer. Just a few seconds before liftoff, the flight program software will take control of the launcher.
So that's what happens during the synchronized sequence. That's coming up now. There'll be a lot of vital operations happening during that time, won't there?
Yes, it's a very complex sequence of operations. All is timed to milliseconds.
À tous de DDO, attention pour la séquence finale lanceur. Top H04 minutes.
So we've now begun the synchronized sequence. The range operations manager there, Jean-Frédéric Alassa, announcing the beginning. You'll be hearing his voice making all the major announcements throughout today's launch. So we have a number of control rooms on the job today. We saw them earlier. Obviously, we've been looking a lot at mission control. We fondly call it Jupiter here at the Spaceport. The teams at mission control overseeing the whole mission. And then, of course, we saw earlier launch control. The launch controllers are very much concerned with the rockets and the pad and all those preparations prior to launch, Irene. I mean, what are they doing in there?
Yes, the launch control center is called Pandora. Probably is a reference to the mythological figure of Pandora box, symbolizing the transition from a sealed, controlled state to the complex and powerful deployment of a mission. The teams here are in charge of preparing the rocket and checking it. They monitor all these final operations before liftoff. And of course, after liftoff, the rocket goes on autopilot. The teams inside Pandora are three. There is the technical authority team. They define the launcher and specify the way it is operated. The operational team. They conduct and coordinate all the activities, strictly following procedures prepared by the specialists. And the quality team. They ensure that everything complies with the stringent standards required for a safe and reliable launch.
And we also have a control room working in parallel in Colleferro, which is where your HQ is at Avio, just outside Rome.
Yes, it is the so-called base arrière. They are checking the launcher's behavior in parallel. They are analyzing data and watching every parameter, every reading on the launcher. All these people come from different teams, such as propulsion, structures, control, and they are ready to jump and support in case of need. This is our rocket, and today we are launching it.
You must be feeling quite emotional. We're getting
Yes.
close now. 1 minute and 42 seconds to launch and counting. Vega, standing tall on its pad with its lightning masts around it. I guess this can be quite a tense moment.
Yes, I think concentrated is a better word. It's really emotional, even if they are done so many times, each time is so unique. Right now, the boards are green.
À
And
12 de DDO,
everything is ready.
attention pour moins 1 minute. Top, H0 moins 1 minute.
We are 1 minute to launch. We're live at the European Spaceport in French Guiana, and SMILE is about to begin a journey that will change how we see Earth's magnetic shield forever. Good luck, everyone.
Buona fortuna.
À tous de DDO, attention pour la séquence finale. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, top. Allumage P120 et décollage. Propulsion nominale, début du basculement. Fin du basculement. Tous les paramètres à bord sont normaux.
We have liftoff. SMILE has started its journey on board Vega-C, lighting up the night sky as it flies above the European Spaceport here in French Guiana. The range operations manager telling us that the propulsion is nominal. We are heading northeast out over the Atlantic Ocean, and we can hear the rocket now in our commentary box. It's taken this amount of time for the sound to get to us. It lifts off so fast, doesn't it?
Tous les paramètres à bord sont normaux, la trajectoire est nominale.
And we're burning the P120 at the moment, the first stage.
Yes, the name comes from 120 tons of propellant, but now it's fatter, it's 140.
It's gained weight.
However, he has a very thrust-to-weight ratio, so its thrust is double the mass. So we have 2g of acceleration. This means twice the value of gravity.
And we've passed something called the transonic region. What's that?
Yes, the vehicle is now quicker than the sound, the velocity of sound, and now is in supersonic
Propulsion nominale.
He's telling us that the propulsion is nominal, everything's going well.
La trajectoire est nominale.
Yes.
We can see our rocket in the night skies here. We can still see that P120 engine burning.
Yes, we are towards tail-off. So the stage separation windows is open, and we are waiting for the separation command.
Séparation du P120.
We have
Allumage
confirmation
Z40.
there from the range operations manager that we have separated the
La propulsion est
first
nominale.
stage, the P120, and ignited the second stage, the Z40, and he's telling us that propulsion is nominal. We've reached Mach 6.
Trajectoire nominale.
Now we are 6 times quicker than the sound.
And we've started what we call the dogleg maneuver.
Yes, the dogleg is the name of coming from the shape of this maneuver. It's a very steep
Tous les
maneuver,
paramètres à bord sont
and
normaux.
it's done just after the ignition of Zefiro 40 because you have very low loads, aerodynamic loads, and so you can also do maneuvers very, very steep. And this normally due for safety reasons like geographical constraints or visibility constraints.
And we're burning, right now, we're burning the Z40, the second stage.
Yes, and now we are also protecting we have also with some seconds we will be so high that we will be able to release the fairing, because the fairing is useful when you are in the lower part of the atmosphere. When the density is decreasing, you can release the fairing.
And we get a very good shot there of the fairing. This is our animation of what's been planned for the journey. You can see the fairing is that bulbous section.
Yes.
The front of the rocket, the top of the rocket
Yes.
is containing our satellite. And as you
Yes.
say,
it's very important because it protects the SMILE from aeroacoustic vibration at liftoff and from friction during the lower part of the atmosphere. And it protects from aerodynamic loads and also on thermal loads.
Trajectoire nominale.
The trajectory on the left-hand side. The green line is the planned trajectory, the yellow line, the actual trajectory, and that's
Allumage
how
du
it
Zephyr
looks
9.
when we lose the Z40. And he's
Séparation de la
confirmed that we've switched on the Z9, the next stage, and we have jettisoned the fairing. As you say, we're now in space
La propulsion
effectively,
est
and we
nominale.
don't need it anymore. And he's telling us the propulsion is nominal. So we are now burning the Z9, the third stage, the Zephyr 9.
It's a very powerful stage. During this phase, the speed goes from 15,000 to 27,000 kilometers per hour. That is about 30 times the velocity of a commercial aircraft.
That's fast. And we can see SMILE, it's the gold structure. It's actually now exposed to the cold vacuum of space for the first time. Can you just talk us, say, from right to left, Irene, what we're looking at? On the right-hand side, obviously, we can see the engine burning, and then the white structure in the middle.
Yes. Sure, Katie. The white part is the motor, so the Zephyr 9 and the AVOM. Then you have the black conical structure that is the payload adapter. This is to support the payload and also to push it when we are reached the target orbit with a gentle release with 4 springs. And the gold is obviously the satellite that is protected with a cover for thermal protection.
And the gold stuff is the thermal protection. And these, as I mentioned earlier, these are computer-generated images. They are showing us a simulation of what's been predicted for the launcher in real time. So it's not actual camera footage from space, but it gives us a great view of what's happening, a visualization. And these are the tracking stations, Galileo in French Guiana, and the tracking station at Saint-Jean-du-Maroni.
La propulsion est nominale.
We have twisted and facing upwards. Why is that?
Yes, this is the so-called neutral axis maneuver. It's performed just before the separation of Zephyr 9 to orient correctly the Zephyr 9 before separation and make it re-entry in a predefined zone.
And just briefly, we've also started something called closed-loop guidance.
Yes, you are right. And during Zephyr 9, we have the so-called closed-loop guidance. That is a guidance that recomputes on board the desired trajectory, considering the actual state of the launcher.
Séparation du Z9.
So it keeps us on track.
Fin de visibilité de Saint-Jean.
And we've separated the Z9. It's burnt its propellant. It's done its job. We don't need it anymore. And we are now, there again is a good view of our tracking stations and our flight path. So, Irene, right now at this point, normally we would switch on the upper stage. The upper stage is that white disc that you can see there. But we're not doing that today, are we?
Yes,
Why is that?
Indeed, that's right, because SMILE is quite different from a sun-synchronous orbit mission, and so we have to wait about 13 minutes in coasting phase before igniting again the AVOM. And in this phase, the launcher is just controlled by roll and attitude control system.
So we're in a coasting phase right now. And actually, we've got a good view of SMILE now, and you can see that it's actually got a very bulbous shape to it. That's sort of the gold structure being kind of very, very bulbous. It's the only way I can think of to describe it. And that's actually the fuel tanks, isn't it?
Yes.
And we've got a lot of fuel on board because we're going a long way. We've got to travel a third of the way to the moon. It's a long way.
A very long journey. So after the launcher release, the satellite will have to travel a lot, up to 120,000 kilometers of apogee and 5,000 kilometers of perigee. And so to do this...
Apogee being the furthest away, perigee being the closest to Earth.
Yes, you are right. And to do this, it has to perform several racing orbit maneuvers, and to do this job, this propellant is needed. We have almost 1,600 kilograms of propellant here.
That's
a very big amount for a satellite.
That's a lot of it.
Yes, you are sure.
And so did the fact that it's carrying so much propellant on board, did that give you any challenges in terms of designing the mission?
Yes, a lot of challenges because the fuel is losses. So we have to be very careful in order to check that it doesn't interact with the launcher dynamic. So this is why it's important to simulate and verify every detail.
Well, you've done some very good work in doing that. And if you just look at your screen there on the left-hand side, you can see there on the animation that we are actually twisting very, very slowly. So effectively, we're barbecuing.
Yes.
And that is the technical term.
Yes, you are right. This is the barbecue, and this is used to avoid having the solar that is facing always on the same face. So with the barbecue, we can have the same constant temperature across the launcher.
Indeed, we're barbecuing as if on a spit, rotating. Right, now, once SMILE gets to its vantage point, it'll be able to look down and image the full sunlit edge of Earth's magnetic field. It'll also photograph the northern lights, which is rather something because no mission has ever done that before. And here's the thing, it'll give us actual images of Earth's magnetic shield reacting to the solar wind. That's quite something because the magnetosphere is invisible to the human eye, so this is a completely new way of seeing our planet's protective bubble in action. I'm absolutely delighted that joining me is the Director of Science at the European Space Agency, Carol Mundell. Carol, thank you so much for coming up to see us in the commentary box.
Thank you, Katie. It's great to be here. I'm just catching my breath.
Hang on a sec, I'm just switching your microphone on. Yeah, I was just saying thank you so much for being with us.
Thank you, Katie. Thanks for having me here. I'm just breathless from that absolutely spectacular launch. I mean, we're all stunned. And it was such a beautiful view out there on the terrace and the clear night sky. We just saw it for many, what felt like many minutes. But
it was incredible. It really lit up the sky, didn't it?
It did. It was fantastic. So congratulations to our launch teams. They've done a great job so far, and long may that continue.
Yes. Indeed. Let's see how we go. 11 minutes and 32 seconds into launch right now. So, Carol, let's just talk about SMILE. Let's talk about the magnetosphere. Let's start at the beginning and just explain to anyone who's not familiar what is the magnetosphere.
Yeah, so the magnetosphere is actually the Earth's magnetic field. So we think at the center of our planet is a liquid iron core, and that produces a magnetic field, a large-scale magnetic field. Now, what happens to that magnetic field is it's actually shaped by the solar wind. So we have an Earth-Sun system, and the sun produces radiation and flows of charged energetic particles, and that actually shapes our Earth's magnetic field to make this protective magnetic bubble that, as you said, protects our planet and actually makes life on Earth possible. Otherwise, we would be toast.
Yes, which wouldn't be a good place to be.
Not really.
So effectively, then the particles from the sun, they kind of bounce off the magnetic field and they fly off into space and they go around us.
Some of them do, and that's one of the big questions that we'll use the SMILE mission to answer, because obviously at the front, the sun side, the daytime side, we actually have what's called the magnetopause, and then at the back there's a magnetotail, and actually some of those charged particles sometimes leak down through the weaker magnetic field particle edges through magnetic reconnection, and that then produces the aurora and the interaction right down to the ionosphere, which is actually where the SMILE acronym comes from, because it's that solar wind magnetosphere ionospheric link explorer, which is actually what SMILE means as an acronym, and we have other reasons for calling it SMILE too.
So what's SMILE going to do, and what's it going to tell us? Where's it going to be, and what's it going to do?
So what SMILE's going to do now, obviously, it's on its way on the rocket, and gradually it will actually be released, but it will then continue actually to be, over the next month, will reach up to 120,000 kilometres above the North Pole. So it'll be a very elliptical orbit. It will swing down 6,000 kilometres above the South Pole, download its data, and that will be the orbit for the next 3 years. And it will be a revolutionary transformational mission, as you said, for the first time making the invisible visible, but actually that continuous monitoring of the dynamic Earth-Sun system, taking those first X-ray images, continuous monitoring in the ultraviolet of the aurora, and then also we have 2 other instruments on board that will make direct measurements of the Earth's magnetic field to compare with the X-ray images, and a direct probe of the particles that are reaching Earth. So for the first time ever, we'll have a global system view, a dynamic view of cause and effect. And ultimately, although that's incredibly important for our scientists, and our scientists will do their work, they will pass their knowledge and insight onto more operational teams who care about space weather and the predictions for geomagnetic storms that arise when the sun goes into its most active phases and really starts to impact our Earth system.
And it's not the first spacecraft, is it, to look at the magnetosphere?
It's not, and actually we have a long pedigree. So over 20 years ago, we launched the cluster mission on an Ariane 5, actually, from Kourou, and that was the first time we had 4 spacecraft, which was very revolutionary at the time, taking the first 3-dimensional data of the Earth's magnetic field. Also, our Chinese colleagues had the Double Star mission, and again making those point measurements and giving us a little glimpse of what that system is about. We also have our solar missions, such as Solar Orbiter, which is really studying how the sun works and what's coming from the sun. So for the first time with SMILE, we'll be able to put all of that together and have an unprecedentedly complete global system picture.
And this has been quite an amazing collaboration, wonderful collaboration, hasn't it, between the European Space Agency and China?
It has, incredibly. I mean, way back in 2005, ESA and China signed a cooperation agreement. So that's really the framework that lets us work together. But of course, how do we want to work together? What do we want to do? So we've had some collaborations, for example, like Cluster, Double Star. We've also provided some instruments for Chinese missions, most recently Einstein Probe, to study new black holes in the universe. But this is the first time, and it was really very revolutionary to think about how we would devise bottom up, asking our European and our Chinese scientists to come together to propose a mission that would be devised, built, implemented, and operated 50-50 between our two communities.
And what kinds of discoveries are you hoping for? I mean, what makes you all feel excited at the moment?
I mean, as I say, I think, I'm a scientist by background. I've worked on magnetic fields. They've always felt a bit of a niche. They're always hard things to explain. They're always incredibly fundamental, but very difficult to study and to understand. So to suddenly be able to make images, to take X-ray images, to take the legacy of things that we've done on other missions within ESA, such as XMM Newton, one of our X-ray missions, take that technology and bring it into a new sphere. But it will also be measuring the interplanetary magnetic fields and disentangling those. So I think the science will be fundamentally breakthrough. But for me also that real world impact, because at the moment we do have models of what might happen if there is a solar storm, how it might impact our satellites or our ground electrical subsystems. But the predictions are not accurate enough yet for operational use, because we miss this complete fundamental understanding of the whole system. So those little glimpses that we've had don't constrain the models well enough. So for me, I think we're going to see a big step forward also in the operational protection of our planet from space weather.
And just briefly, before we go, Carol, just talk us through some of the exciting things ahead in the future.
Yeah, I mean, it's so exciting to be here, Katie, for SMILE, because obviously we have so many missions coming through in our ESA program. We had our ministerial conference last year where our 23 member states came together and uplifted the science budget as a vote of confidence in the quality of the program. We celebrated our 50th anniversary at ESA, science program 51 years old now. And so actually we're answering some of the biggest questions. Why are we in the universe? Is there habitability? Are we alone? What's the nature of the universe? So we have a new mission that we will launch next year to look for Earth-like planets around Sun-like stars, so solar systems like our own. We will then launch the Ariel mission, which will study the atmospheric chemistry of 1,000 planets and other solar systems. And then we will go right out to our LISA mission, which is the world's first ever gravitational wave interferometer to actually sample the nature of space-time itself. So from habitability to life out there, right through to the nature of space-time itself. I mean, it's an exciting time we have ahead.
Wow. It really is, isn't it? Watch this space. It's wonderful. Thank you so much, Carol. Thank you very much for coming and talking to us, and good luck with the rest of the mission.
Thank you.
So to get SMILE to its all-important vantage point in space, we need to start by parking it in a temporary orbit close to Earth. That's where we will inject it into space, and it's going to take us about 40 minutes to get there from here. We'll need to ignite the Avon Plus upper stage twice during that time, and the first firing is scheduled in a couple of minutes' time. So, our flight path, Irene is back with us. Irene, where are we?
Yes, now we are still flying over the Atlantic Ocean. The launcher then will pass over Northern Europe, then across Russia, and China and South Asia, reaching Australia when it will be ready to deliver the satellite. And then we continue back towards South Pacific and North Atlantic up to the orbiting when it is over Iceland.
And we're tracking the rocket using telemetry. From the moment it leaves the pad, there's a network of ground stations watching its flight. Basically, the rocket's what is effectively communicating with us, isn't it?
Yes, that's the ground station. It's how we can communicate what is the status on board. So it tells us, for example, how the engines are performing, the fuel that is left, the temperature, the exact position.
Acquisition de la télémesure par la station Svalbard.
He's just telling us that we have picked the signal up now at the tracking station in Svalbard, which is a Norwegian archipelago in the Arctic Ocean, roughly halfway between mainland Norway and the North Pole. Yes, what you were telling us about the telemetry.
Yes, it allows to track the flight in real time. And telemetry is how we know if the rocket is healthy.
So we are coming up now on the next moment. We have confirmation from the range operations manager that we have switched on the engine on the upper stage and everything's going normally and going well. So the Avon Plus has now taken the wheel for the next leg of the mission, and it has a very important job because it has to transport SMILE to its injection orbit where it will then be released into space. So this is really where SMILE's journey gets interesting, isn't it, Irene? It's a very sophisticated piece of technology.
Indeed. Avon Plus is very accurate and also flexible. It's accurate because it is due to the thrust control and the very accurate cut-off impulse. The flexibility is linked to the flexibility is due to the fact that you can ignite it several times, up to 8 times. So you can really deliver a satellite and then continue your mission to deliver other satellites.
Yes, because sometimes you do have more than one satellite on the same rocket.
Yes, it is not this case because SMILE is a single payload mission, but in other missions we had released several payloads in different orbits. It's like a space bus.
Dropping off at different bus stops. A quick word about our speed. We're travelling at 7.39 kilometers per second. It's very fast.
Yes, 30 times faster than a commercial aircraft.
So as the tracking stations collect the data from the launcher, they relay it to the teams here at the Guiana Space Centre. We saw them earlier. We can see them on the left-hand side of the screen there, focusing hard at this point. It's called the Quick Look Telemetry Team, or the CVI. What are they doing?
They are receiving real-time data from the launcher about propulsion, control and trajectory. And this allows them to monitor the launcher's behavior.
L'orbite atteinte par le lanceur est stable.
And they can, of course, confirm if the satellite is separated as planned.
And Irene, for the first ever Vega flight back in 2012, you were in there, weren't you?
Yes, you're right. I was in CVI 14 years ago, so in 2012, for the first flight of Vega. So it was really impressive for me to have this dream becoming reality, because I was seeing all our simulations that were really becoming true in our screen.
How wonderful. And they have their own internal comms loop, so they pass the information of the confirmations and the milestones to the range operations manager, and who then announces those confirmations to the base. So we are now getting closer to switching off our engine. How does it know when to switch it on and off?
Yes, the upper stage has its brain, that is the onboard computer. So it's what brings the launcher to life. Without it, the launcher will be just an amount of structures, propulsion, wiring, without no way to function as a system. So this is why we can have a real mission from liftoff to the orbiting, thanks to the onboard computer.
So how does it actually execute that mission then? I mean, how does it know where it is, what it's supposed to do?
Yes, the functions that are inside the onboard computer, the main functions is the navigation, guidance, and control function.
Well, that's your speciality,
yes.
isn't it?
The navigation provides you the positions and the attitude you are sensing through your inertial measurement. The guidance provides you the desired trajectory to be followed, while the control tracks the trajectory to be followed thanks to the actuators. So the thrust vector control and reaction control system.
So this is the
extinction de la VOM.
The moment we switch off the engine on the AVM upper stage, we have that confirmed. And so we have now entered, again, another ballistic phase. That means we're traveling without propulsion. We are coasting without the engine. So we're about 25 minutes now into the flight, but of course the teams have been working here at the Spaceport for weeks and weeks getting the rocket and the satellite ready for today's launch. We call that process the launch campaign.
Yes, we can run several launch campaigns in parallel here at the European Spaceport. This is very good for our customer because we can increase our launch rate.
He's just telling us that we're orientating for the barbecue mode. So the parts of Vega-C are built in Italy and transported here to the Guiana Space Center where they're assembled. What's been happening during the launch campaign?
Yes, the AVM upper stage and the shell of the first stage, the P-120, arrived on board of a sailing ship called Canopy. The P-120 was then transferred to the launch zone slowly using a special track. The other stages arrived at the port of Kourou on board another ship, Colibri. The Zefiro 40 traveled by track to the launch pad, where it was tilted and integrated on top of the first stage. The integration platform for Zefiro 40 is about 29 meters from the ground. We follow the same logic of the third stage, that is the Zefiro 9, is transferred to the launch zone, then is tilted and lifted onto the second stage for the integration on the platform at 35 meters. Finally, AVM arrived in its container by road, is lifted on the upper platform at about 40 meters from the ground level and mated on top of the third stage. You can see the platform inside the mobile gantry that gives the teams access to the launcher. The Smile arrived in French Guiana by boat. It went to the dedicated satellite preparation building at the Spaceport, where it was carefully unpacked. The teams wore protective suits to fill the tanks with propellant. They tested Smile and mated with the payload adapter. And finally, the whole thing is enclosed inside the fairing. And finally, the whole thing was enclosed inside the fairing. The ventilation inside the fairing was then adjusted in order to assure the best condition for the spacecraft And once completed, the payload assembly is transferred to the launch zone and lifted and mated on the top of the launcher.
And the Range Operations Manager was just confirming there that the orbit is correct. So behind every launch campaign and countdown, there are all kinds of people involved in building the satellite and the rocket. Their expertise carries the launcher and satellite from the factory floor to the launch pad.
Yes, it only takes a few seconds for a rocket to lift off from the pad, but every launch is built on years of expertise and dedication from the team.
Indeed. The Avio teams manufactured Vega and designed the mission, so they know the rocket better than anyone. They've lived every challenge. Let's step behind the scenes and meet some of them.
There are many aspects which help the mission to be successful, but if I would have to retain only one, I would refer to the team excellence, the team motivation, the team spirit, which is very important, especially when you have people from different cultures.
In this mission, I have to verify that operation adds no extra pyrotechnic and safety risk and adds no extra exposure for the workers. My role is to bring safety rules into reality. When risks are mitigated, we can focus only on the flight.
Our engineering team works hand in hand with our partners from Avio in such a way that we respect the right level of quality, from the mission preparation to the manufacturing of the stages to the integration until the launcher is ready on the pad.
My most important responsibility is ensuring coordination across all teams, so I focus on the strategic decision making to keep the ground availability aligned, safe and efficient.
When we see Vega on the launch pad, we have a sense of pride and satisfaction of the work done. But at the same time, we have to be cautious and content because we have not yet completed the mission. And only when we see that the spacecraft has been released on the right orbit, we leave way to our joy.
It's a powerful mix of responsibility and pride. You feel the weight of every decision,
Fin de
but
visibilité
also the distance of achievement.
Svalbard.
Knowing the efforts of all the teams
Perte
comes
attendue
together
de la
in that
télémesure
final
pour
goal.
environ 22
rocket
minutes.
is extremely powerful, and you put on top your satellite that you've been working on for 10 years, and then you send it to space. So of course, it's extremely exciting. It's super exciting.
I feel like I do the best job in the world. It's a mix of focus and pride. We turn sweat into emotion.
But it's also a little bit sad because you are basically saying goodbye to the child that you've been working on with the hundreds of people in your teams in China and Europe, and it has to accomplish its mission, which it is designed for. So I'm sure it will be all okay.
Oh, so much passion, so much dedication. Right, we are going to take a break. We're going to be taking a break for about 16 minutes, about a quarter of an hour. So we'll come back to you at 1:39 a.m. here in Kourou. That is 4:39 Universal Time. That's 6:39 in Rome, Paris, Central European Time, and 12:39 p.m. in Beijing. See you back here then. Don't go away.
You.
So this is really a milestone. It is really a milestone. It is really a milestone. Can you hear me?
Welcome back to our YouTube Live, Vega Go. We are 48 minutes into the journey of SMILE, the spacecraft on board Vega-C on its way to its orbit. I'm Katie Haswell, joining me still...
Irene Cruciani.
Irene Cruciani.
From Avio.
From Avio. Irene, it was a beautiful launch, wasn't it?
Yes, indeed. A very beautiful launch. Up to now, everything was as expected. We lifted off at 52 minutes after midnight here in Kourou, and then we separated the 3 stages nominally. Then we had the first Avon burn, leaving the launcher in the so-called transfer orbit, where we are now.
And the next phase will then be to sort of head towards the separation. But first of all, let's just take a look and see what has happened so far, get a look at the story so far, if you like, and what's planned for the mission upcoming. So that gives us a really good idea of SMILE's elliptical orbit and how it's going to climb higher and higher into space. So coming up on the next key event, the
Acquisition de la télémesure par la station Ionosphere.
AVM ignition, and the range operations manager has just told us that we have picked up the signal now at the Ionosphere tracking station.
Tous les paramètres à bord sont normaux.
Which is in southwest Australia. So our flight path has brought us down to Australia, and the team's there now tracking the
Orientation
next
en vue du deuxième boost avant.
So what's happening up there in space? He's just told us we're orientating for the next boost.
Yes, before we were barbecuing to keep constant temperature all around the launcher, but now we are started the pointing for the right attitude to prepare the Avon second burn.
And barbecuing, of course, just a reminder, is a rotation to keep the temperatures nice and even, because it's very hot when you're facing the sun and very cold when you're facing space.
Deuxième allumage de l'Avon.
Confirmation that the second
Propulsion
burn has
nominal.
occurred. The Avon Plus upper stage has switched
Very good,
on.
very good. This burn is quite short.
Trajectoire est nominale.
It lasts just a couple of minutes, and is used to put the launcher in the circular orbit where we will release the satellite.
Our speed there on the bottom right hand of the screen, 7.27 kilometers per second, and right now we're at an altitude of 705 kilometers. So we're nearly on our separation orbit, Irene. We need to deliver SMILE onto exactly the right orbit in the correct orientation, don't we, so that we can set it off, if you like, on the right path.
Yes, Vega-C stage is extremely accurate in delivering the spacecraft, thanks to the precision of its propulsion system, actuators and navigation. And after separation, SMILE will continue its journey alone to reach the final orbit, a highly elliptic orbit, shaped like an oval.
Indeed, and the furthest point, as you said earlier, is 121,000 kilometers above Earth, and its closest point 5,000. But why does it have to come so close to Earth?
Yes, so an elliptic orbit is surely less energetic than a circular orbit, so it takes less fuel for the satellite to arrive there. And then you have a very long time staying at high altitude, so you can take the image you need for the magnetosphere. And then when you approach at the perigee the Earth, you can download the data in an efficient way. So it's a very clever orbit.
Our trajectory on the top left-hand side of the screen, the green line, our planned trajectory, the yellow line, our actual trajectory, bang on there.
Deuxième extinction de l'Avon.
And we have the second extinction confirmed. We have switched our engine off. And he's telling us that the orbit is correct.
Début d'orientation en vue de la séparation du satellite.
You can see the Ionosphere tracking station, and he's just announced there the beginning of the orientation.
Yes.
For separating the satellite. Is
yes,
that right?
you are right. Before we can separate the spacecraft, the launcher needs to be with a real precise pointing. So it is needed to orient towards the sun, the solar panels, when they will be deployed. And the launcher orients it thanks to the reaction control system, that is pointing system for the ballistic phase. And this is important because we have to be very stabilized when we release the satellite, and the angular rates shall be very low, under 1.5 degrees per second.
And how does separation work?
So the separation works with the 4 springs in the payload adapter. We have 4 springs that gently push the satellite to have a safe distancing from it, from the launcher towards the satellite. And so this is really important to keep the safety of the release.
Séparation du satellite SMILE.
And he's confirmed that we have had separation of the
Orbite
SMILE
atteinte à la séparation
satellite.
correcte.
And SMILE, you can see it there, moving gently away from the mothership, having been sent into space by that set of springs
Début des manœuvres d'éloignement.
that you just described. And he's just said we're starting the moving away move.
Yes, we have a collision and contamination avoidance maneuver after separation in order to be sure to stay far from the satellite.
So the teams at the Chinese Satellite Control Center and the European Space Operations Center will now be taking on their new satellite. They'll be going through a process to check it's in good health.
Yes, the spacecraft operation will now progressively take control of the satellite. They will deploy the solar panels, perform some health tests, and verify that everything is functioning properly on board.
So now we need to wait for confirmation that SMILE is sending its signal, and also confirmation that it has deployed its solar panels.
Yes, this could happen while we are still in the range of New Norcia, that is within 7 minutes from the separation, and otherwise we have to wait. But now it seems
we're getting some very happy faces.
Yes.
And some claps.
So I think,
which makes us think that we may have some good
Confirmation de
news.
l'acquisition du signal satellite et du déploiement des panneaux solaires.
Fantastic news there.
Fantastic news.
So the Range Operations Manager has announced that we have A, received the signal from the satellite, and B, deployed the solar panels. So that's wonderful.
Wonderful news. Everything is perfect.
So huge congratulations to so many different teams involved in today's mission. It's a very, very important satellite, and it's also a very important day for Avio, because today Avio became, for the first time, a launch provider as well as a rocket manufacturer. So it's been a historic journey.
Yes, you're right. Congratulations to the Chinese Academy of Science, the European Space Agency, all the industrial partners, the Guyana Space Center, and also my colleagues in Avio.
Yes, congratulations to all of those people. So right now, the teams, let's send our very best wishes to the teams, the Chinese teams and the European teams who are flying the satellite, because SMILE has to go through a whole set of different tests now.
Yes, before going towards the real operative part of this flight.
We can see here the people in the Pandora CV, the Launch Control Center, so their job is done right now. You can see the operational teams in the fishbowl. There's Carol Mundell, the head of science at the European Space Agency, who came and talked to us earlier, told us all about this wonderful satellite, and no doubt over the moon, that it's now in space, going through its next phases. So let's go over now to Giulio Ranzo. Back to Giulio, the CEO of Avio. Giulio, so good news.
Yes, good news, excellent news. The satellite was separated nominally, so exactly in the place where it should have been, and it was able to deploy its solar panels, a maneuver that it was counting on executing over the first few seconds after separation. So it all went well. We're very, very happy about that, very happy about the partners, and so we should at this point thank them once again, the European Space Agency and the Chinese Academy of Science, for their trust in us as an operator. We see applause in the room, so everything has gone well. And let me take this opportunity to thank the European Space Agency for their continued support, and in particular I would like to thank the French Space Agency CNES for their assistance throughout the preparation of this flight. It all went well as we expected. And last but not least, I would like to congratulate with the Avio team for an excellent job on conducting their first mission as a launch operator.
Absolutely. Massive congratulations to you and to everybody. Giulio Ranzo, thank you very much indeed.
Thank you, Katie.
So, SMILE has wings. SMILE has called home and said hello. So let's now go over to the Director General of the European Space Agency, Joseph Aschbacher. Hopefully, we will hear from Joseph. In the meantime...
Today, we open a new window of understanding into how our planet interacts with the Sun, thanks to another successful launch of Vega-C. For the first time, we will observe Earth's response to the solar wind simultaneously in X-rays and ultraviolet light. By improving our understanding of solar storms and the resulting geomagnetic disturbances, SMILE will strengthen the scientific foundations of space weather research. This knowledge is essential to better protect space-based infrastructure, critical services on Earth, and the safety of humans in orbit. In an increasingly space-dependent world, this is science with real and tangible consequences for our societies. SMILE was built on scientific collaboration and international cooperation. Over a dozen European countries have directly contributed to building the spacecraft, and more than 250 European and Chinese scientists formed the SMILE consortium, working together on the mission's scientific objectives and on the analysis of the data to come. As a joint mission between ESA and China, SMILE reflects how ESA approaches international cooperation, working openly and responsibly with clear frameworks wherever there is clear scientific benefit. I would like to thank everyone whose dedication, professionalism and expertise have made today possible. The SMILE's journey has just begun, and with it, a new chapter in our understanding of the Sun-Earth system. Thank you for your attention.
Great to hear there from Joseph Aschbacher, and some very important words. So here we go. Look, we can see the teams there. Irene looking very happy and very excited.
Yes.
They'll no doubt be having their photographs taken. And
we're going to have a party.
Yes, there will be a party. Because people have worked so hard. I mean, this has been such an important launch in so many different ways. Hoping now to hear a few words from some of the key players in today's mission, and the industrial teams who made it possible. Let's go over now to Professor Qi Wang, who is the director of NSSC at the Chinese Academy of Sciences, the co-principal investigator for the SMILE mission. Ione Martinez is the SMILE payload manager for Airbus Defence and Space. And Geraldine Naja is head of space transportation at the European Space Agency. Let's start with you, Geraldine. Congratulations on a very successful launch. I mean, you must be over the moon. You must be really delighted.
Confirm. I'm totally delighted. It's a wonderful success.
Congratulations to everyone. It has been a perfect launch. Perfect launch. Fully on time, separation exactly when it was planned, so we are extremely happy. So now, first of all, congratulations to everyone. This launch was, as I said, 3 times unique. It's the first single joint mission between ESA and China, and it's a huge success of international cooperation. Scientifically, it's a wonderful launch with a wonderful mission with so many instruments to better understand how the Sun works with our planet and interacts with our planet. And last but not least, it was the first Vega launch operated by Avio, and a complete success. So congratulations to Avio, to all the teams. Another thing I want to mention is, of course, that this, let's say, launch once again confirms how well-suited Vega is to launch small to medium science missions. It shows that we were right to entrust SMILE to our Vega-C launcher. And I would like to say this is not yet over because, of course, Vega-C will continue to evolve. Soon we will have an even more powerful first stage with the P160C. We will also further continue to evolve Vega and towards Vega-E. So we will continue to prepare let's say, the future of space transportation in Europe, building on all that we have already done. So I can say today is a real day of pride for Europe, for China, I hope, for all the scientists that have been working on this mission, for all the companies, the industries that have worked both on the platform, also on the payloads. So well done, Vega-C. And good trip to SMILE, which is now on its circular orbit, but will soon go into its final highly elliptical orbit to bring us, once again, wonderful results from the science teams. Well done.
Yes, indeed, and well done, everybody. And Professor Qi Wang, what a fantastic partnership between Europe and China, and what an important milestone for science.
Yes, it's a really milestone. And this is the result from what we have done for more than 10 years. A huge thank you to everyone and the CAS and the ESA and the Avio and the CSA. We are proud of what we have achieved together. SMILE is a real mission now. It will be the first time to show how the solar wind meets Earth. It will study the interaction of the solar wind with magnetosphere. SMILE is more than a satellite. It's a proof of what we can accomplish for science when we work together across the globe. The adventure starts now. We are looking forward to the first image and the data. Congratulations to the entire team. Let science begins.
Ione Martinez, Airbus Defence and Space, led the European teams. It's been fantastic teamwork, hasn't it? You must feel very proud.
It's a very emotional and proud moment for all of us. So seeing SMILE being successfully launched aboard the Vega-C rocket is the result of years of effort, dedication and perseverance. So we are really happy and somehow relieved to see that we are progressing towards the next step of the missions after a long journey and very intensive on Earth. At Airbus, we want to thank you, all Airbus teams that have worked side by side together with all the industry. We want to thank the customer chain for the trust, and a special mention to Avio for an excellent execution tonight. This is very important as it is the maiden flight with Avio as launch services provider. So we are willing and looking forward to providing service in the commissioning and next phases, as well as we are ready to reinforce our position as key industrial partner for the future with our customers. Congratulations to all the SMILE community.
Indeed, massive congratulations. And congratulations to you. Congratulations to everybody. So there it is. SMILE. It's sent its signal. It has its solar panels. It's on its way, and so mission success. Congratulations to everybody involved in making it such a success.
Yes, to Chinese Academy of Science, to ESA, to CNES, and all the industrial partners. Yes. Thanks.
Yes, and best wishes now to the operational teams as you take on your new satellite. Thanks as well to the TV production teams for making this live broadcast possible. And finally, my thanks to you, Irene, for lending us your wonderful expertise. Thank you so much.
Thanks, Katie, for inviting me.
It's been lovely
So
having
now
you.
we have a smile in the sky.
We have a smile in the sky. We will be back next time. But from me, Katie Haswell.
And Irene Cruciani. Bye.
Bye-bye. That was nice.